Titrations are a method that we can use to determine the concentration of an unknown solution. So, for example, if we have some sulfuric acid that's sitting in a beaker in the lab, and it's just labeled sulfuric acid, and we don't know what the concentration of that sulfuric acid is, what we can do is take some sodium hydroxide that we do know the concentration of, and react it with the sulfuric acid until the solution is neutralized. So in this first example here, where the solution is clear, we haven't added any sodium hydroxide yet. This pink color comes from an indicator called phenolphthalein, which is one of the indicators that we can use. So you can see some pink color starting to form, but if you were to swirl this beaker, that pink color would likely disappear. And then when we get to the point where the sulfuric acid has been neutralized, now we have a solution where the pink color is noticeable there, and it will stay pink even if you swirl the solution around. So we know the concentration of our sodium hydroxide, and we know how much sulfuric acid we have because we can measure the volume of sulfuric acid, and we know the volume of sodium hydroxide we used, so we can use that to calculate the concentration of the sulfuric acid. So that's all a titration is a way of determining the concentration of a solution that we don't know the concentration of. So the solution that we know the concentration of is a standard solution. Sometimes that's called a titrant, but most of the time we call it the standard solution. The equivalence point is the point when the moles of the standard solution or the titrant are stoichiometrically equivalent to the moles of the substance being analyzed. So we've added the same number of moles of our standard solution as we have of moles of the substance being analyzed. And the endpoint is the point at which our indicator changes color. So really, titration is just a fancy word for solution stoichiometry. It's the exact same thing we did with stoichiometry, just we're doing it in solution, so we're using milliliters and liters and molarity instead of grams. So let's take a look at an example here. We have 20 milliliters of sulfuric acid reacts with 48.6 milliliters of 0.100 molar sodium hydroxide. And we want to know the molarity of the sodium hydroxide. So molarity, if you think back to when we defined molarity, molarity is moles per liter. And we're already given the milliliters of sulfuric acid, which we can convert to liters. So what we need is moles of sulfuric acid in order to be able to plug this in. So the way that we do this is you always start with the one that you know everything about. You start with the one that you know the volume and concentration of, and you work towards the one that you don't know something about. So we're going to start with the 48.6 milliliters of 0.100 molar sodium hydroxide, and we're going to use that to figure out how many moles of sulfuric acid we have. So I have 48.6 milliliters of sodium hydroxide, and I know that molarity is moles per liter, which means that I need to convert milliliters to liters. So there's 1,000 milliliters per 1 liter. And then, according to my solution here, according to my problem, I have 0.100 molar sodium hydroxide. So remember, molarity is moles per liter. So what this means is that I have 0.1 moles of sodium hydroxide per liter of sodium hydroxide. So I can make this into a conversion factor. I have a liter of sodium hydroxide on the top here, so I'm going to put liters on the bottom and moles of sodium hydroxide on the top. And then I want moles of sulfuric acid. So according to my reaction, 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. So this gives me the moles of sulfuric acid. Now if I take 48.6 times 0.100 and divide that by 1,000 times 2, I come up with 0.00243 moles of sulfuric acid. So now I have moles and I already have milliliters, because I can convert the 20 milliliters to liters. So 20 milliliters divided by 1,000 liters gives me 0.0200 liters. So to calculate the molarity of sulfuric acid, moles per 0.0200 liters. So if we divide that out, we come out with 0.122 molar sulfuric acid. So let's try another example. What is the concentration of sulfuric acid if 15 milliliters of it reacts with 18.45 milliliters of a 0.0973 molar sodium hydroxide solution? So we have the reaction for sodium hydroxide and sulfuric acid on the last slide. And we're going to start with the sodium hydroxide because we know the volume and we know the concentration of sodium hydroxide. So we have 18.45 milliliters of sodium hydroxide. And since molarity is moles per liter, we have to convert milliliters to liters. One liter of sodium hydroxide, we have 0.0973 moles. And then we showed on the last slide that 2 moles of sodium hydroxide reacts with 1 mole of H2SO4. So if we take 18.45 times 0.0973 and divide that by 1,000 times 2, we come up with 8.98 times 10 to the negative 4th moles of sulfuric acid. And if we convert milliliters to liters, 15 divided by 1,000 comes out to 0.01500 liters. So if we want to calculate the molarity molarity as moles per liter. So we take 8.98 times 10 to the negative 4th moles, divide that by 0.01500 liters. And if you divide that out, that comes out to 0.0598 molar sulfuric acid. Okay, let's look at one more example here. If 30.34 milliliters of a 0.135 molar solution of hydrochloric acid were required to neutralize 25 milliliters of sodium hydroxide, what is the molarity of the sodium hydroxide solution? So we're not given the reaction this time, but this is a reaction that we've seen before. So if we take hydrochloric acid and sodium hydroxide, this is an acid-base reaction. So we know one of our products is going to be water, and the other one is going to be the salt that's left over, which in this case is sodium chloride. And it just so happens that this reaction is balanced as it is. So now we can start working through to figure out the concentration of our sodium hydroxide. So this time we know the volume. The volume and the concentration of hydrochloric acid. So we're going to start with that one and work towards sodium hydroxide. So we have 30.34 milliliters of hydrochloric acid. So we're going to convert that to liters. And then for every 1 liter of hydrochloric acid, we have 0.135 moles of hydrochloric acid. And then 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So if you divide that out, take 30.34 times 0.135 and divide by 1,000, you come out with 0.00409 moles of sodium hydroxide. And then we want to neutralize 25 milliliters of sodium hydroxide. So if we divide 25 by 1,000, that comes out to 0.025 liters of sodium hydroxide. So if we take molarity as moles per liter, so we take the 0.00409 moles, divide it by 0.00, add an extra 0 here. .02500 liters. And if you divide that out, that comes out to 0.164 molar sodium hydroxide. Okay, so this wraps up titrations, and I will see you in class and we will get some more practice with this.